They're the giants of the agricultural business, and farmers the world over drive them across their fields to harvest their crops. Be it grain, rapeseed, or corn, the largest model in the T-Series, the T670, can harvest as much as 50 tons an hour. Combine harvesters are the kings of crop harvesting vehicles.
Yeah, it's a bit like lawn mowing for adults.
Zweibrücken in Rheinland-Pfalz is home to one of the largest combine harvester plants in Europe. Nearly 1,100 people work here, producing 20 of these giant harvesters every day.
The combine harvester is a factory on wheels, more than just a machine.
Modern combine harvesters are controlled using GPS. As they're only in use from 20 to 30 days a year, the two most important things are efficiency and reliability.
Even the tiniest leak can be spotted quickly underwater.
The plant even has its own diagnostics track, where it puts every harvester to the test.
The sieves, the blower, the hillmaster, the unloading apparatus, all the functions offered by the machine.
When in the field, its throughput is huge. The combine harvester can fill its grain tank in less than 20 minutes, after which it has to be emptied. Zweibrücken. This is the location of a gigantic combine harvester factory, serving the European and international market. 6 a.m., the shift begins. Nearly 1,100 people work here, most of whom are production workers. The plant produces various harvesters, the biggest of which is the T670 combine harvester, a harvest factory on wheels. While the industry is dominated by men, the plant is under the leadership of a woman, and she primarily focuses on two things: developing the machines and improving working conditions in the plant.
This means that we are doing a great deal, naturally with a focus on ergonomics and load handling equipment, to ensure that our older and female employees can also work here. While our largest market is Europe, we supply our equipment around the globe. Our combine harvesters can be found in China, Australia, South Africa.
The T670 is 9.2 meters long without cutting equipment. And with its maximum height of 4 meters, it's one of the largest agricultural vehicles in the world. From tire to tire, its outer width measures exactly 3.49 meters. This means that it's allowed to drive on German roads with a special permit. The T670 can also be equipped with crawler tracks if desired. These reduce the pressure on the ground while simultaneously improving traction. This machine can harvest some 50 tons of grain an hour. The dead weight of the combine harvester is 21 tons. Its diesel tank holds 800 liters. The grain tank behind the cab has space for 11,000 liters of crops. The T670 can also be unloaded during operation through the unloading tube at a rate of 125 liters of grain a second. The machine is powered by a straight 6-cylinder engine with a displacement of 9 liters and 455 horsepower. The top speed is limited to 40 kilometers per hour, a factory on wheels.
The first order of business is harvesting the grain. The grain's then fed into the machine where it is threshed. In other words, the grain is removed from the straw. Then the grains are separated and the straw is chopped up to be distributed on the field or laid out in the windrows. The machine is extremely versatile.
Every combine harvester starts off in the sheet metal shop. This gigantic punching and pressing machine is the industrial counterpart to a Swiss Army knife. It can directly access 20 tools, allowing it to produce more than 500 different parts. The presses are supplemented by 6 laser cutting machines. They cut nearly 1.7 million parts a year.
It can handle a lot of sheet, and it doesn't stop when confronted with thick sheet. With 10mm sheet, a panel takes about an hour, up to 1.5 hours, depending on how many small parts it contains.
After the parts are cut, they're bent in the bending press. This presses the parts into the precise form desired with millimeter accuracy, using up to 400 tons of pressure. The parts are then joined in the welding shop. Large sheets are joined using a spot welder that delivers up to 450 amperes to the brass tip, allowing it to spot weld even thick sheets with ease. A combine harvester has numerous functions. While the front of the machine is cutting the stalks, the threshing drum rotates up to 1,350 times per minute inside the machine to separate the grain from the chaff. The threshing unit is the heart of the combine harvester. And it's with this unit that assembly begins. Parts are put together and attached by hand, then welded by robots.
We don't want anyone to suffer machine failure or faulty welds in the field. That's why it's so important that each weld be 100% correct. That's the reason this task is generally performed by robots.
After a good 2 hours, the right side of the thresher unit is ready. This is when assembly begins on the assembly line. The right side panel is finished. Now, the next step is to install the auger base with the blower, the upper sieve box, and what is known as the chaff sieve frame. The threshing unit will be the heart of the combine harvester. The rollers that will end up threshing the grain run inside this unit. Should one of these rollers become defective later, it's almost impossible to replace it without disassembling the entire combine harvester. The thresher unit's drums rotate nearly 1,400 times a minute during the harvesting process. As they thresh, separate the wheat from the chaff. The units are assembled in a complicated manual process to ensure that all of the rollers run absolutely smoothly. This involves attaching metal plates to a shaft. These will later be used to hold the blades. A computer system helps employees as they assemble the drums.
To ensure that each worker always uses the correct torque for each bolt, our tool support system specifies precisely which tool is to be used, the right tool. The wrong tool is not released for use at that point, which means workers can only remove the correct tool and therefore apply the correct torque.
Once the mounting process for the drums is finished, they're fine-tuned. Much like car tires, the drums are checked this way to identify any imbalances.
The imbalance comes from the materials, from the strips. They're not all the same weight. If they aren't corrected, the rotations and centrifugal forces would generate vibrations in the machine.
To avoid this, a laser identifies the exact locations where balancing weights need to be placed, so that the drum will run perfectly later on. A combine harvester is far more than just a rotating drum. Marketing expert Matthias Berger from Product Planning knows what his customers expect from a combine harvester.
The combine harvester is a factory on wheels. It's more than just a machine. It harvests the entire crop wherever grain is being cultivated. In other words, it cuts the crop and feeds it into the machine where it's separated. This means we separate the grain from all the other elements like leaves and stalks. Then the grain is cleaned and collected in the grain tank. And when this tank is full, the load is transferred to another vehicle.
The cab is at the front. This is where the driver sits as they direct the combine harvester through the field.
This is the cab where the combine harvester's driver can be found when operating the machine. Spacious and with a great all-round view, of course, because the driver has to be able to see what's going on here. Fully air-conditioned with an air-cushioned seat is even more comfortable than a sofa. And it had better be. On long harvest days when you're working for 12 or 14 hours, it goes without saying that you need a comfortable workplace if you're going to stay fit. The driver can operate everything from the cab. They only actually use the steering wheel when they're driving on roads. In the field, navigation takes place automatically using GPS. During this time, the steering wheel is moved forward and no longer used. Instead, the driver controls the machine with the primary joystick. They're able to see what the harvester is doing in various monitors. They can also see what else is happening and what's being harvested, as well as the quality of the crop.
Back to the assembly hall. The left side panel of the threshing unit is now being mounted. This means that the drums are attached to both side panels. From this point onwards, the entire combine harvester is assembled around the threshing unit. This also includes welding the front axle mounts to the threshing unit. The gigantic front wheels are mounted here at the end of the assembly line. Now we move on to a new location, Bad Camberg, just north of Frankfurt am Main. Rainer Eichhorn is a third-generation farmer, and he has both a T670 and an S780 in his fleet. He drives one of these himself, his colleague the other. Every year when harvest time comes in the summer, he works all out all the time. Over the next 20 days, he has to harvest some 1,100 hectares. That's roughly the area of 1,500 football fields. Work usually begins between 7 and 8 in the morning because the fields have to be dry. The first order of business is cleaning the machines. A mechanical defect or even a total breakdown in the fields must be avoided at all costs.
We're performing a visual inspection here. We need to see what the belts look like and to make sure that none of them are loose, if there are any leaks. To be certain that there aren't any nasty surprises during the day ahead. But everything looks good. Everything's all right. That's what I'm used to seeing.
At a cost of up to 500,000 euros, a combine harvester is a major investment for any farmer. And depending on the weather, the harvest period is only about 20 or 30 days a year. Every hour that a defective vehicle is out of operation is money lost. To be able to use the combine harvester, however, the farmer also requires other vehicles, such as a tractor to pull the cutter bar trailer.
This has a cutting width of 9.15 meters, and its external width is just under 10 meters. It's clear that you couldn't drive on the road with this apparatus, which is why it's necessary to have a separate transport vehicle in which the cutter bar is carried separately.
The costs of harvesting are also determined by the current price of diesel. However, with a combine harvester, the consumption is not determined primarily by the distance driven as it is with a truck, but rather by the volume being harvested, as well as the type of harvest.
When we have to harvest a really good field of grain, one in which there's a particularly high share of straw and grain, we obviously use a bit more fuel. With crop varieties yielding less grain, the diesel or other fuel consumed will be less. That's why it comes down to what we are harvesting.
Once the field is reached, the first order of business is mounting the cutter bar. Rainer Eichhorn has positioned his vehicle with the crawler tracks at the front. These reduce the pressure on the ground while simultaneously improving traction. This also reduces the overall width, something that is important on narrow roads. The cutter bar is mounted to the front of the combine harvester and driven by the vehicle's engine. There are 4 different cutter bars available from accessory dealers. Every farmer has their own ideas and their own preferences, but the principle behind every cutter bar is the same.
Here at the front, we have the blades. These are responsible for cutting the stalks. The harvested crop, in other words, the stalk with the husks, falls into the auger, the round component with the spirals. This is the feed auger, and it rotates. It feeds all these stalks with their husks of grain here into the center, where we have the intake drum that feeds into the center of the combine harvester, into the thresher.
The T-Series are what can be referred to as shaker machines. This means that these machines have an impact tool, a threshing drum. These drums thresh the grain from the husks. However, this must be done with care in order to not damage the grains. It's also essential that no grain remains in the husks. Once past the threshing drum, the separated grain falls down into the grain sieve. The straw, on the other hand, is passed through the shakers to the back, where any remaining grains are shaken out of the straw mat. Hence the name Shaker Combine Harvester. The straw then falls onto the field behind the combine harvester. The grain is collected in the grain tank, which has a capacity of 11,000 liters. But the grain is only in this tank very briefly. That's because the unloading vehicle is always nearby during the harvest.
We have 3 different tank capacity detectors installed in this tank. One of them tells us when the tank is just half full, another when it's 3/4 full, and finally one is for when it's completely full. That's when the unloading auger is used to transfer the grain to the transport vehicle.
This unloading process takes place while the vehicle is in motion, meaning that the combine harvester can continue harvesting and the farmer doesn't lose any time. Back to the main plant in Zweibrücken. The finished combine harvester body, that is, the thresher unit's 2 side panels with the drums, still has to pass through a series of cleaning and degreasing immersions before it's ready to be painted. These ensure that even minuscule residues of oil or other impurities are removed.
We have rinsing baths, degreasing baths, there's a phosphate conversion coating, and then we get to the actual dip bath in which the part is immersed, followed by more rinsing baths.
This is followed by electrophoretic painting, which is also known as e-coating. Electric current is used to give the combine harvester's chassis a positive charge, while the water containing the paint is given a negative charge. The body and paint therefore attract each other, resulting in an evenly spread coating on all of the parts. 6 hours later, the chassis is dry, and it's given its vehicle identification number. Then it's painted again, this time by hand, using a total of 80 kilograms of paint.
This not only delivers protection against rust, but also a high level of UV protection. That's because the machine is subjected to a high level of solar radiation. This also protects the primer, not to mention the fact that it constitutes the finish and ensures an attractive appearance for the customer.
After this, the body has to dry again before it's done. After 5 hours, it's finally ready for transport to the assembly line. The body of the combine harvester alone already weighs nearly 8 tons. On to a new location, Bruchsal, near Karlsruhe. Here, roughly 900 employees are busy producing the cabs for the combine harvester and other vehicles.
Right now, our production program for the season comprises about 3,500 units, including combine harvesters and other equipment like shredders. We produce approximately 21 units, 21 cabs a day.
The combine harvester's cab consists of a floor, side panels, back wall, and a roof. These are positioned inside a blue assembly frame and then manually attached to one another by hand using spot welding. There are 3 employees in the welding shop during every shift. Only experienced employees work here because it's essential everything is precision welded. As soon as the construction is stable, it's sent into the robot booth. That's where all the welds are finished.
The way the workstations are configured now, we have experienced people doing the work. When we get new employees, they're trained before being entrusted with a task. If I'm learning a new workstation, it takes about 6 weeks or so.
Once the cab has been fully welded, it still needs to be painted. It's suspended from a hook on a rail system and sent on its way. Over the next approximately 1.5 kilometers, its first stop is the paint shop, where the cab will be scanned in and then painted black. Now the cab begins its journey to the assembly line. For this, it's placed on a yellow robot cart, which automatically takes the cab from station to station through the plant. The assembly of the cab begins in Station 1.
This is where everything is unmasked. This means that all the protective caps are removed. Then we install insulation here at the back to reduce noise so that it isn't as loud as in the cab. Then it's off to Station 2, where the wiring is installed.
Every 24 minutes, the cab moves on to another station. That's what's known in the industry as the cycle time. In Station 2, the wiring harness and electrical components, such as a subwoofer, are fitted in the cab. This is but one of a seemingly endless list of accessories from which customers can choose to configure their vehicles. At the next station, the back panel is fitted. This also contains the combine harvester's rear window.
Now I have to press this on to ensure that the adhesive goes where it's needed, like this. Then I further secure it with these clamps at the side.
Now all the gaps are filled because the finished cab has to be watertight. Because combine harvesters can only harvest for 20 to 30 days a year, their working days are often as much as 20 hours long. That's why engineers in the development process always try to maximize the driver's comfort. And that's why these panels are installed inside the cab. In addition to the driver's seat, there's also a passenger seat. This is a fold-down seat to the driver's left next to the door, and it's always mounted first. Only after this is done is the large driver's seat fitted. The operating panel that the driver uses to control the combine harvester and all its functions is mounted on the driver's seat. Then the cab moves on to the next station. Now it's time for the steering column, with the steering wheel that is used to steer the combine harvester when driving on the road. When they're out in the fields, they're controlled fully automatically using GPS. Now comes what is certainly the most frequently ordered accessory for the cab, the refrigerator, which is fitted beneath the passenger seat.
The customer spends a long time in the field in the cab, so they have to have cold drinks. Costs extra but can be fitted. I'd say 90% of the people get one.
Now it's time for the front window. This is bonded the same way the back panel was. Finally, the cab receives its roof, in which the headlights and rear-view mirror have already been mounted. And naturally, UV protection for the driver. The combine harvester also comes with a radio as standard. In order to install the electronics in the roof, there are still 2 covers needed. The cab is rotated for assembly.
This is where the lower roof goes. My colleagues install the upper roof.
Both the GPS antenna and the radio antenna for communicating with other vehicles in the field are installed in the roof. The cab is nearly finished. Now it's time to start with the first tests. First up is the tightness test, which is conducted with a frequency device like this one. The transmitter is placed on the driver's seat, from where it sends an ultrasonic signal. Now the employee uses the receiver to see whether all of the gaps and crevices have actually been properly sealed.
If there were a leak anywhere, it would show up here. If I even tap right here or open it slightly, the device immediately emits a signal.
Once this test has been completed, the cab is brought to life for the very first time. To do this, it's connected to the electrical power supply and the machine is started up. This is the first time that the ignition is turned on. Now all the electronic components, including the radio and windshield wipers, are tested. Should anything be defective, it will be replaced immediately. The cab does not leave the assembly line until all of the functions have been tested.
Everything's working just right.
Now there's just one stress test left, the water test. Seeing as many farmers regularly clean their vehicles using high-pressure cleaners, cabs must also be able to withstand high pressures of up to 120 bar. In principle, it's the same as a car wash, but with high pressure.
Now this checks the bonded windshield, the bond, to ensure it is sealed. And with the water, you can spot even the tiniest leak immediately. And now the high pressure is going around the cab. The front is checked first, then the sides near the floor mat, right and left. Then we take another look here at the ceiling strip to see if everything's fitted securely and if the cab's sealed.
Once this test too has been passed, the cab is ready for shipment and placed into intermediate storage outside. Every day, 4 times a day, a truck takes 6 cabs from Bruchsal on a journey of more than 100 kilometers to the assembly plant in Zweibrücken, where production is completed. And because every cab is assigned to a specific combine harvester, the cabs must always be where they're needed. Harvesters have a long history at John Deere. The company entered the market back at the beginning of the 20th century, when their first machines cut the grain while it was still green and bound the stalks together. Threshing was still a long way off back then, but the technology never stopped getting better. Soon, a particular configuration took hold. The driver, front and center, in a raised position, with the grain tank and engine at the rear, an arrangement that has been proven its worth up to the present day. In the 1970s, the fields began growing larger and larger, meaning that the machines had to keep doing more because the harvest period is always the same. In the 1990s, GPS entered the fields and revolutionized the harvesting process. Now, combine harvesters were also able to navigate, and with the introduction of mobile data, they were transformed into factories on wheels. Since 2015, yields have been measured automatically, meaning that farmers can see precisely where and when they have harvested, and most importantly, just how much. Back in Zweibrücken, where one of the biggest assembly plants for agricultural machinery in Europe is located, every day some 20 combine harvesters leave the production halls. This is where the grain tanks are kept as they await installation. Each one of these is designated for a combine harvester chassis. The grain tank holds 11,000 liters and can be emptied while the vehicle is moving. When harvesting at full speed, this means having to empty it around once every 20 minutes. To ensure that the right combine harvester always gets the grain tank assigned to it, the sequence in which the components are placed on the assembly line is extremely important. These magnetic number tags are used to avoid mix-ups.
The numbers are simply to assist employees, because it goes without saying that there are many different options and variants of these machines available. It's on account of this variety that the entire production line relies on manpower and logistics running smoothly in the background.
Because space in the plant is limited. This ensures that only the parts on hand are the ones that are next up for installation. Like this small rear axle here used for steering the combine harvester. The large mounts for the huge front wheels are not steerable because they are firmly attached to the chassis. Next up, the grain tank and the chassis. These are the 2 biggest parts of the combine harvester, and they comprise the framework for the vehicle as a whole. The other large assemblies are the driver's cab and the engine. During the final assembly, the combine harvesters are moved about with the assistance of these self-propelled carts. They run along a rail system and take the vehicle from one station to the next.
They're loaded here at the front and travel with the combine harvester through the assembly line and are returned here to our turntable. That rotates and we start over again in the first cycle, where the AGV is reloaded with the combine harvester.
Should an employee step in front of one of these, it stops automatically.
The laser scanners create 2 safety fields in front of the dolly. And when anyone enters its outer safety zone, the dolly slows down, as we can see here. And if I enter into the front safety zone, it comes to a complete stop.
Self-propelled dollies are also referred to as automated guided vehicles, or AGVs. What used to be done manually is now done by a self-propelled dolly that never gets tired. And the next AGV is quickly given a new job. It's the chassis to which the grain tank was mounted just a few minutes ago. A crane is now used to place the combine harvester on the self-propelled dolly. These two will remain a couple from now on until the time that the combine harvester is completed at the last station. Once both parts have been bolted together, the combine harvester begins its journey down the final assembly line. There are still 22 more stations before it's finished. The first job is to mount the cab. The cabs are delivered in the same order as the jobs, so that they always have the right cab for the right combine harvester. In Germany, the process of mounting the cab is also referred to as a wetting.
The key point here is the fact that a cab can weigh anywhere from 800 to 900 kilograms. You always have to work very slowly with suspended parts to ensure that the machine is placed precisely where it should be.
Finally, there's a danger of collisions down here, alongside and inside the machine. That's why almost everyone working on the assembly line wears these bump caps, baseball caps with extra protection.
As we can see here, a plastic protector that can also be replaced if it breaks. Yep, just pop it back in like this. Like a helmet, but lighter, and it looks good.
At the next station, the huge grain tank flaps are fitted. Each flap weighs roughly 120 kilograms. These will be closed whenever driving on public roads. Inside the grain tank, it's now time to mount the unloading equipment. This unit uses an auger to transport the contents of the grain tank into the unloading tube. On to another location, Bad Camberg, just north of Frankfurt am Main. Farmer and contractor Rainer Eichhorn and his partner Jens Bernbach have been driving the T670 for many years now. Their harvest region starts in southern Hessen and extends north to the Taunus area. This means they are on the go for nearly 6 to 8 weeks when harvest time comes around each summer. Including breaks for rain, on average, there are between 20 and 30 harvest days a year. These are long days, and they always start with the same ritual.
Now we're going to pick a husk of wheat and separate it. Basically, we're doing by hand what the combine harvester does on a much larger scale. We're separating the wheat from the chaff and sifting the grain from the husk. A quick puff of air, and then we use a nice little trick I learned from my granddad. You take a grain of wheat and bite down on it. If it cracks, it's dry. And then we can get started.
Farmers usually wait until the dew from the night before has dried completely. Then, around 10 or 11 a.m., not long before midday, harvesting begins. It won't stop again until dew forms.
At the front, the cutter bar has sensor strips fitted at the bottom that measure the working height multiple times each second and automatically keep the cutter bar at the right height. Yeah, it's a bit like lawn mowing for adults.
Bernbach doesn't just harvest his own fields. He also offers his harvesting services to farmers who don't have their own combine harvesters. In these cases, he's paid according to the quantity harvested. The combine harvester deposits the straw behind the vehicle in what are known as windrows. This straw will later be used as bedding for the animals.
Here, the combine harvester is depositing the stalks in rows. This is a grain stalk, a wheat stalk, and this is where you'd normally find the husk. The harvester has removed and threshed it. This stalk will be used as bedding for horses or cows, for example, and to ensure that we do not have the straw lying pell-mell in the fields, but that we can instead collect it mechanically, the combine harvester deposits this straw in straight rows known as windrows, so that I can use a different piece of equipment to collect it and create these round rolls, these bales.
When harvesting at a rate of 50 tons an hour, you can fill up an 11,000-liter grain tank pretty quickly, which is why it has to be emptied every 15 to 20 minutes.
The grain tank is full. If we look at the window behind us, we can see that it is now covered by grain. And here we can see on the display that it's currently 81% full. It overflows when it reaches 100. That means it's time to start unloading now. We've got the driver with the trailer here on our left. I radioed to tell him to come. Once the vehicle's in position, we begin the unloading process, and the grain from the combine harvester's grain tank will now be transferred to the other vehicle through the unloading tube. so that the combine harvester never has to stop moving.
Both drivers maintain the exact same speed during the unloading process. The combine harvester is now unloading its grain into the companion vehicle at 125 liters a second. The tank is never fully emptied, however, because it's being continuously refilled throughout the harvesting process. Once the field has been harvested, Jens Bernbach detaches the 9.15 meter wide cutter bar from the combine harvester. Then he puts it onto a trailer so that a tractor can transport it by road. In other words, the combine harvester can never work alone. It always needs its own little fleet. Once everything has been packed up, it's time to return to the farm buildings, where the auxiliary vehicles have unloaded a small portion of today's harvest. As always, Bernbach finishes the day by examining his own work.
We have to ensure that the combine harvester does not thresh the crop too intensively so that there are not too many crushed grains. But that's not the case, so everything's okay. This is about 20 tons, and as a rule of thumb, I'd say that's enough for about 400,000 rolls.
Breakfast for an entire city. A new location, Orléans-Serein, south of Paris. Engines have been manufactured here since 1963. 800 men and women are producing diesel engines for the company's own agricultural equipment. The engines are also used for other vehicles, like construction machinery and ships. From the engine block to the connecting rods and the crankshafts, every component of the six-cylinder engine is built right here. Nearly 100 engines leave the plant every day. Every single one of them is subjected to a stress test following assembly, and none are allowed to proceed to final assembly until they have passed it. And only after they've been painted, of course. In addition to the plant in Zweibrücken, this French facility also supplies John Deere's tractor plant in Mannheim. Back to the main plant in Zweibrücken. Here, the combine harvesters are receiving their engines. To this end, the straight six engines are placed in an engine mount. The engine has a displacement of 9 liters and delivers an impressive 455 horsepower. Over the next few hours, the engine will be equipped with additional components like an exhaust outlet and exhaust gas treatment system. This ensures that the combine harvester is in compliance with current EU emissions guidelines. This is followed by the gearbox housing for the many belts that will be driving the internal components. The gigantic blowers also mounted at this time. The entire drive unit now weighs about 4.5 tons and is placed onto the combine harvester. Everything has to be exactly in position. The end of the assembly line is still nowhere in sight. The inclined conveyor is now installed at this station. This is what the cutter bar is attached to in the field. The grain is fed into the combine harvester via the inclined conveyor. Both the inclined conveyor and the cutter bar are also driven by belts connected to the vehicle's engine. The vehicle has reached the halfway point of the assembly line, and it now moves on to the next station, where the combine harvester is filled with all its fluids for the first time. To do this, the dolly carrying the combine harvester travels onto a turntable, and the machine is rotated. Exhaust gases are not permitted to enter the production hall when the engine is started, so they're extracted. Then the combine harvester is fueled up for the first time.
The machine is given a complete fill-up here at the station. This includes all the fluids, hydraulic fluid, diesel fuel, refrigerant and coolant. Then it's time for the first test run.
In particular, this includes monitoring the belts, although this can only be done from a distance for safety reasons. And naturally, the grain tank mechanisms. If the first test run is successful, the combine harvester is sent to a test hall, in which it is subjected to close inspection by employees, with all of the belts and settings being tested while operating at full capacity. All the employees are linked together through their headsets during this process, so that they can communicate with one another. The same rule applies every time the process is started.
Turn on the ignition, take a look at the mirrors, use your headset to tell your colleagues, be careful, we're about to start. Then the horn is blown, we wait 10 seconds, then the engine is started.
This gives everyone enough time to get out of the danger zone before the machine starts running. Faults are documented digitally as well as photographed. These must be rectified before the vehicle can be delivered. Now the combine harvester is setting off on the final meters of its production process, with trim and decals being mounted at these stations. Because the combine harvesters will be put to work all over the globe, it has to be possible to operate them in various languages. And there are some 200 different stickers for this purpose. The only one that is the same everywhere is the obligatory Deere, which is attached behind the reversing camera at the back using adhesive. The last major component is now delivered, an unloading tube that can be up to 7.5 meters long. Due to the fact that it has to be bolted onto the vehicle at a right angle, it's not installed until the last possible moment. Later on, this unloading tube will be used to empty the grain tank while the harvester is in the field, at an incredible 125 liters a minute. Once the tube has been mounted, it's folded in for reasons of space. Now, the combine harvester arrives at the last station on the assembly line. Having reached a weight of 20 tons, lifting equipment is used to raise it off of the self-propelled dolly. This T670 is being equipped with 26-inch rims and tires at the rear. The external diameter is 1.53 meters, and each one weighs nearly 255 kilograms. On a 32-inch rim, the front wheels are considerably larger. Their external diameter is 1.9 meters, and they weigh nearly 550 kilograms each. The final assembly process has taken 11 hours in all. The combine harvester is then raised by a second lifting system, this time one located beneath the tires, and the dolly departs. This is when the combine harvester touches the ground, or rather the factory floor, for the first time in its still very young life. The tires are not new. Seeing as the combine harvester is still being moved around the plant, we install used tires. The new tires are not fitted until delivery. But the combine harvester is still far from being finished. The next thing on the agenda is the driving test, which will be done here on the in-house test circuit. On to a new location, Großwalmstorf Farm, between Lübeck and Wismar. In order to show just how much a combine harvester from the T-Series can really harvest in a single day, the test is being done here. The harvest begins at 9 a.m. The factory on wheels will now be controlled via GPS and harvest continuously for as long as weather conditions permit. As it does so, every single kilogram of grain is weighed and documented. Drivers will be working in shifts so that the harvest can go on without stopping. And just like in normal operation, the grain tank will be emptied on the fly. The combine harvester automatically adjusts its speed over the course of the day in accordance with the changing moisture content of the straw. This increases particularly rapidly when it begins to get dark.
It's now 11:44 p.m. and conditions have changed faster than we'd expected them to. Right now, we're operating with an underlying moisture level of 15% or more.
With a threshing moisture level of over 30%, the working day is finished for the T670 shortly before midnight. In almost exactly 14.5 hours, the machine threshed an incredible 640 tons of grain. Back to the assembly plant in Zweibrücken. As many as 400 combine harvesters come off the assembly line here every year. Before they're delivered, each one of these vehicles has to complete the company's own test circuit.
We inspect the sieves, the blower, the hillmaster, unloading, all the functions offered by the machine.
The test takes 3 hours. The gas pedal is not used to accelerate. The entire combine harvester is controlled using the joystick.
We have a joystick that allows us to select forward or backward travel and can use these buttons to increase the engine speed. It's sort of like the gas pedal in a car. If I move the joystick to neutral, the machine will remain stationary. When I pull back on it, the harvester drives in reverse and it goes forward when I push it forward.
Finally, the unloading tube is also tested. This can be extended, after which it empties the contents of the grain tank into an auxiliary vehicle. If the combine harvester passes the test, there's only one test left before it's ready for shipment. In the inspection hall, the inspectors look for any damage that might have occurred during assembly or in the course of the driving test on the company's own circuit. They have a special dark room for this purpose, a hall with no light whatsoever. To this end, a fluorescent dye was mixed with the hydraulic fluid during assembly.
This dye mixes into the fluid during the driving test. As a result, when we shine a black light, any possible leaks will be visible since the hydraulic fluid has a neon yellow color. This means we can tell if the system is sealed or if a leak has occurred during operation.
Following the darkroom test, the T670 is given one final inspection in daylight, because it's essential not only to ensure the absence of leaks, but also of even the tiniest scratches, not even on parts that get scratched as soon as they are used in the field, as in this case with the spreader disc.
Here, for example, it has a scratch on the power dispersion disc on the left. We record this and document it.
The combine harvester should arrive at the dealer without even a single little scratch. That's why the spreader will be replaced before delivery. This is noted down accordingly in the digital vehicle folder file, along with a photo. At the last station in the plant, it's time to say goodbye. The combine harvester is prepared for transport in the loading hall. First, the wheels are removed. These were only mounted for the test circuit and for traveling around the plant premises. While the combine harvester is being raised by its axles, the new tires are arriving outside. The combine harvester should arrive at the dealer and at the customer with brand new tires. These are delivered separately by truck. This means the transport vehicle is not as wide, allowing it to drive on European roads without a special oversized load transport permit and without the need for an auxiliary vehicle. A crane is used to place the combine harvester on the truck trailer. Even without tires, it weighs 20 tons. The combine harvester must be perfectly centered. Once the load has been secured, the combine harvester sets off on its first big journey. The machines that are destined for overseas markets are usually transported to Zweibrücken in Belgium, where they are put on ships. The others are taken directly by truck to their destination. Combine harvesters are the giants of the agricultural business. Factories on wheels. Be it grain, rapeseed, or corn, these state-of-the-art combine harvesters can harvest as much as 50 tons an hour. Zweibrücken in Rheinland-Pfalz is home to one of Europe's largest producers of agricultural machinery. Nearly 1,100 people work here, producing 20 of these combine harvesters every day. When they're out in the fields, modern combine harvesters are controlled using GPS. Since they're only in use from 20 to 30 days a year, reliability and efficiency are the two most important things. Combine harvesters, the kings of crop harvesting vehicles.